Now, there's actually a lot of data types in Python, but the two most common numeric types by far are integers and floating point. If you've used any other programming language, you already know all about all these, but I'll review it. An integer is simply a number. It could be positive, negative, could be 0, has no fractional portion. Floating point numbers are very similar. They can be positive, negative, 0, but they can contain fractional portions. And that's important. Sometimes 2.5, you cannot represent that as an integer. You can certainly represent that as a floating point number. Now, integers in Python have this incredible feature that I call infinite integers. They're not really infinite because in order to store an infinite value on a computer, the computer would have to be infinitely large, bigger than the universe, bigger than an infinite number of universes. Obviously, it can't do that. But integers in most languages are very limited. For example, 16-bit integers, I think that can only be as big as 64K. But integers in Python have no limit other than the physical limitations of the system. And this is kind of exciting because integers can store astronomical values far beyond the limits of other languages. And you don't need to do anything special to get these. This is a property of integers in Python. It's amazing. And for example, you can even store a Google, and you'll see I have two different ways of spelling it. People get upset about that. I don't know, but a Google, in any case, is 10 raised to the 100th power. That is 1 followed by 100 zeros. And to give you an idea of how big this number is, it's far bigger than the number of atoms or even the number of elementary particles in the entire physical universe. Unlikely your programs are going to need to store a bigger number than that. Let's look at a demo, and this demo is going to point out a couple of really important things. It's going to point out the exponentiation operator, and it's also going to show the difference between assignment and test for equality. All right, we're back in idle now in the Python screen. So what I'm going to do now is I'm going to use assignment again, but I'm going to use it to create a number that it's so big, it's as big as 1 followed by 100 zeros. Well, how in the world would we get a number that big? Very simple. We take 10 and then we do star star or asterisk asterisk. No embedded space there, by the way. And we're saying we're raising 10 to the 100th power. And normally, any other programming language you do that with, it will say, I can't handle a number that big. Python, oh, no problem. And let's look. So I'm calling it G now. I'm saying G is a number. G is a name for 10 raised to the 100th power. Let's print it out. Oh, look at that, 1 followed by 100 zeros. Now, that's hard to read, so I'm going to use a little trick. I'm going to introduce a Python formatting method, which we'll explain later. And you can look this up in Python documentation if you want. But simply stated, we have a way here of printing out a number with nice little thousandths separators in the form of commas. So if I've typed that in correctly, it will print out G. Oh, but oh, look, it does print it out with those separators. Isn't that nice? So this gives you a taste for how incredibly powerful Python is as a way of formatting and printing information. I mean, with a few keystrokes, I said put in commas and make the number look nice. It did. This is just a taste of how you can do an enormous amount that we'll see. I've written a function in C to do exactly that, and it took several pages of code. So Python gives that for free. Now, the thing about integers is that they are absolutely precise. And this means that I could actually count to a Google. I would need more time than existed since the age of the universe to do it. In fact, it would hardly get started. But it theoretically could count to a Google. And the reason is because integers are absolutely precise. That means that tiny, tiny amounts relative to the overall size are not thrown away. It tracks the number precisely. And the test for that would be to compare a Google in Python to a Google plus 1, and it should say false. If it says false, that means it understands that these are two separate values. But the important point here, and this is one of the most important lessons you can ever get in programming, because it cost me dozens of hours decades ago when I first started programming professionally. The double equal sign does something completely different from the single equal sign. This is so important, you should really pay attention. What the double equal sign will do is it won't do an assignment, but rather what it will do is it will test the values on either side of the double equals and compare them to see if they're equal. So what we'll get back, by the way, is true or false. It said false. By the way, that's what it should say. Because if I print out Google plus 1, there should be a 1, 99 zeros, and another 1, and yes. So it not only stores a Google, it stores a Google precisely. If I was using floating point, it would not be able to do that. It would confuse those two values. All right, let's talk a little bit about objects and methods. This is a matter of object-oriented programming, and the course does not actually get into object-oriented programming or objects or methods very much, but we talk about objects and methods a lot in this course. The cool thing about Python is everything's an object. Every piece of data is an object. And what does that mean? Well, it's data, but it's also a data with built-in capabilities, and that's really cool. Even integers have built-in capabilities. But the important principle here is that when you use one of those capabilities, you use something called methods. And the syntax for objects and methods is you give the name of an object, a dot, and the name of the method and arguments if you need them. And the object will respond by providing that service. And in Python, every piece of data is an object, believe it or not. Now, if you want to know what those services are provided by every object, what you can do is type help and then the name of the type of the object, and you'll actually get to see a whole list of methods that it provides. One of the methods for the integer class is bit length, and that is simply gives you the number of bits required to store that integer in binary. Maybe not something you use a lot in this course, but it's interesting that even integers have methods. So let's look at one of those methods in operation. We can take the number 5, which is an integer, use the dot notation, which we will come back to many, many times in this course. We can say bit length, which says how many bits are the minimum number of binary bits does it take to represent the value 5 in binary. If you know about binary values, you know that it will take 3 bits to represent 5. We can ask the same question for 8. What's the minimum number of bits? To represent 8, it's 4. And to further prove this, I can use another formatting command. Again, you can look up all the formatting commands in the Python documentation. And if I can type this in correctly, I can format 8. And this should print 8 in binary format. It did. Oh, see, it required 4 binary digits to represent 8. So this is just a demonstration of how even integers have methods. So that shows you how incredibly flexible and versatile Python is. By the way, this is a small point, but if I say 5-point bit length, that won't work because 5 followed by the decimal point looks like a floating point, so that won't work. Now, before we go on, let's discuss a little bit the pros and cons of floating point. This is sort of a review, but before I said, sometimes you have to use floating point because they contain fractional portions. So 1.5 or 3.2, whatever, you're going to have to use floating points. An interesting point here is that if you put in a decimal point, it will be stored as floating point, even though that probably is something won't affect you too much unless you're doing very low-level operations. But the drawback of floating point numbers is that they have limited precision, which leads to rounding errors. For example, I could not count to a Google with floating point. At some point, a rounding error would say, I don't see the difference between a Google and a Google plus 1. So the moral of the story is very simple. Just use integers unless you need to use floating point. But if you need to use floating point because there's a fractional portion, then go ahead and do that. Division works a little different between Python 2.0 and 3.0. Remember, I said that it's important to use at least 3.0 in this course because in Python 2.0, the way I get exact results in division is at least one of the numbers has to be in floating point format. In Python 3.0 and later, / will always do normal division, which will give you a floating point result. So we say 3 divided by 5, we get 0.6. I will always get a floating point result unless I use /, which is floor division. That will give me an integer. It will round down to the nearest integer. And finally, if you want to get the remainder, you can combine ground division or floor division with remainder division, and that's what the percent sign is for. It also gives you modulus. It's also called modulus division. Operator precedence is important. I think it comes up on the exam once or twice, at least. They emphasize operator precedence. We've seen the dot operator. We've seen parentheses. These exceed all other operators in precedence, which means parentheses and the dot operation will be carried out first. We get into arithmetic and arithmetic operators. The highest is the exponentiation operator. Remember, it raises something to a power. After it does that, it will do multiplication, division, modulus division. Below that is addition and subtraction. And then we are going to have a lot of operators that we're going to see later in this course, comparison, Boolean operators. And these are done after subtraction and addition and arithmetic, but they are done before assignment. Assignment, including combined assignment ops, are done absolutely last. So let's look at this real quickly. An expression such as 2 star star 3 star 10. Star star again is exponentiation. It will do that first, then it will do multiplication and division, and finally it will do the addition. Let's look at the x star equal 2 plus 3. Now remember, that's a combined operation. And if it were absolutely true that it was interchangeable with x equals x times 2, well, then we would assume a certain order of precedence, but actually it would be wrong because the assignment operators are always carried out absolute last no matter what. Boolean data is the one other type of data we'll look at for now. Boolean data is always true or false. It's important in evaluating conditions. We saw it with the comparison g equals g plus 1. That was a test for equality. It must always come back true or false. And Booleans are very important, but other types of data are automatically converted to Boolean if they show up in Boolean logic or in an if statement. And Python actually does something very much like the C language. Number, a variable or number, is always converted to true if it's non-zero. It's converted to false if it's 0. And if we try to convert the value none or a blank value, that also gets false. Quickly, we'll look at the Boolean operators. It's obvious what most of these do. The first 6 of these are comparisons. They will come back true or false, always. Now again, I cannot overemphasize this enough. It will save you a lot of programming headaches. The double equal sign is a test for equality. It comes back true or false. The single equal sign does assignment. Very important to get that correct. It's obvious what most of these others do. Test for inequality, greater than, less than. We have the greater than or equal. And finally, we have and, or, and XOR, or XOR, which is the logical exclusive or, either or, but not both. And logical negation, those will all be used to combine Boolean conditions, as we'll see. Before we leave the topic of variables completely, I want to emphasize that variables are just names. We don't declare them. They don't have a fixed type. The attributes of a variable, once again, it's just the attributes of whatever you use it to name. So in theory, if you want to be reckless, you can take a variable x, you can say x equals 1, and that means x is an integer, or you can say x equals this text string, and so x is a string, and then you can say x equals a list. It looks like the type of x is constantly changing. Well, not really. You're just using the name x in different contexts. So you can go ahead and use a variable name to mean anything at any time. It will never stop you. But I have to point out it would be terrible, terrible programming practice. So this is what you should never do, right? And in fact, it is such an issue trying to figure out what a variable does in a Python program that I'm going to recommend naming conventions. So once again, adopting a strong set of naming conventions is strongly recommended. Because you look at a Python program, it says X, well, what is it doing? It could mean anything at any time. It could mean any kind of data. So I suggest you use these naming conventions. Most things are integers, particularly I, J, and K, and an M. Names for floating point values usually begin with X or Y. That's just a good convention. Strings, which we're going to learn about, it's S or S1, S2, S3, or a descriptive name, and then underscore stir. And lists are going to be descriptive name underscore LST, as we'll see. So in summary, the most common numeric types in Python are integer and floating point. And integers in Python are infinite. Basically, they can be astronomically large and still be precise. A floating point is important because it can hold fractions, integers can't. But integers are absolutely precise, and floating point numbers can have rounding errors. And finally, Boolean values are going to be very important in Python programming, and they're either true or false.